So today we're going to take a look at how long until the zombies take over. So if you guys have seen the show The Walking Dead, a disease was contracted that turns people into zombies called walkers. So if a walker bites a human, the human is turned into a walker. And assume that each walker turns one person into a zombie each week and that none of the walkers are killed. So here's a diagram of 140 people. And so a walker, it's that X, and 139 humans. So each walker affects one person each week. So it would infect one more. And then there would be 138. Now each of these would infect two people, one person. So now there's 4. And we'd be down to 134 because, again, total, these are 140. And then what would happen? This would be times 2, so there'd be 8 and 130, or 132. And then this is going to keep growing, right? Oh, did I do this wrong, I think? Let me just rewrite this so I can read that. 132. 16, and that would give us 124 for a total of 140. Doubles 32, so this would just be 108. Doubles again 64, that would drop down to then 76. Double this 128, well, that would only be 12. And if we double that again, 256, but we only have a total of 140. So really, we would max out right here. And they would all be those zombies. So how does the walker population change each week? Well, it's doubling. How long will it take? Well, it looks between 7 and 8 weeks. So list the walkers as a sequence for the first 7 weeks. So the walkers, 0, 1. It didn't start at. So it starts at 1, 2, 4, 8, 16, 32, 64. So what is our pattern here? Again, it's doubling. Graph the relationship between the week and the walkers. So the first week, there's 1, 2, 4, 8, 16, 32, 64. And what was 8 at? I got off somewhere. Let me try this again. 2, 4, 8, 16. Oh, I know why. At week 0, there was 1. So I should have started back here. At week 0, there was 1, 2, 4, 8, 16, 32, 64. Week 7 is 128. So is the relationship linear? No, we're not adding the same thing. So if we look at this next page here, what if we started with 3 walkers? So they each infect. So there'd be 6. So that would be down to 134. Then the next week, let's see, they would each infect 1 person. So there'd be 12. So we would be down to 128. That doubles again for 24. So we'd be down to 116, 48, that would be down to 92, 96, we'd be down to 44. And if I double this, that's 181, 92, so we're over. So we'd have 140 there on out. So how long would it take now? Between 6 and 7 weeks. Or I guess between 5 and 6 weeks it would be. So list the numbers for the first 5 weeks. 0, 1, 0, 3, 6, 12, 24, 48, 96. Well, how is this different? Well, it starts at 3 instead. So if there was infinite, could we figure this out? So meaning, if we were to take this table here, and we would just say week 8. Well, this would be 192. We double that. Let's see, what's 400 minus 8? So 192 and 192. We have 384. If I double 384, 768. So, and now I could keep going. So we could keep going, but I want to kind of figure out 24. So how could I figure out for any of that week? Well, I start with 3 and I multiply them by 2 each week. So, right, times the number of weeks. So we could easily plug in our number of weeks there. Well, how does this one tell us? Well, so it's kind of like this first number is our starting value. And then this is our growth rate, or that it's tripling, right? It triples each week. So a couple things we're going to talk about today. We're going to talk about these exponential equations versus what we've looked at before, these linear equations. So linear we looked at yesterday, that mx plus b. So like if I had 1, 3, 5, 7, 9. Well, what are we doing each time? That has a common difference. We're linear, or excuse me, we're exponential. What's happening here? It has a common ratio. So exponential, we're multiplying. We're linear, we add or subtract the same. And now our exponential is of the form y equals a times b to the x, where this is our initial amount, and this is our growth rate. So if this represents an exponential, well, how are we getting from here to here? Well, this is times 5. So what times 5 gives us 15? J would equal 3 times 5. K would be 1875. So our equation, so our initial, so f of x is our initial times our growth rate to the x power. So if we had to classify linear, exponential, or neither, the average price of the University of Michigan is $146, and it's expected to increase by 5%. So it's always 5% because it is. So that would make it a exponential because you multiply by 5%. Now this next one, I'm hoping we recognize this and see that's a quadratic. So this is neither because it's a quadratic. It's that x squared. Remember, it's that parabola. And then we look at this next one. Well, how do we change from here to here? We're adding 1.5. So this is linear. But here to here, well, times half. We're taking half of it. So this is exponential.